Right now, deep inside the earth in South Africa, miners are working 3.9 kilometers underground, almost 4 kilometers below the surface. That is deeper than the height of the tallest mountain in the Alps. The temperature down there reaches 60 degrees Celsius. The pressure is so intense that the rock walls literally squeeze inward. And in those conditions, thousands of workers drill and blast every single day. For what? For rock that contains, on average, about 5 grams of gold per ton. 5 grams. In 1,000 kilograms of blasted rock, you get roughly 1 teaspoon of gold. And yet gold is the metal that has obsessed, driven, and destroyed civilizations for over 6,000 years. It has started wars, crossed oceans, and built empires. Every culture on every continent has valued it above almost everything else. But how does that 5-gram teaspoon in a ton of rock become the gleaming 99.99% pure gold bar sitting in a vault somewhere? The answer is one of the most fascinating and ruthless industrial processes ever devised. Let's go inside it. Gold is one of the few metals that appears in nature in its pure form. You can find actual gold nuggets in riverbeds. You don't need to smelt it or refine it first. Ancient humans could simply pick it up. That is why gold has been precious for as long as humans have existed. The earliest evidence of gold being worked comes from around 6,000 years ago in ancient Mesopotamia and Egypt. Egyptian pharaohs were buried surrounded by gold because they believed it was the flesh of the gods, literally divine. The mask of Tutankhamun, buried in 1323 BC, is made of 11 kilograms of solid gold. By 550 BC, the Kingdom of Lydia in modern-day Turkey had minted the world's first standardized gold coins, creating the concept of a gold-backed currency that would dominate human economics for the next 2,500 years. The Spanish conquest of the Americas in the 16th century was almost entirely driven by gold. The legend of El Dorado, the City of Gold, sent Spanish conquistadors through jungles and mountains for decades. They never found the city, but they looted enough actual gold from the Aztec and Inca civilizations to completely transform the European economy. The California gold rush of 1848 brought 300,000 people across deserts and oceans in pursuit of gold. It built San Francisco, it populated the American West, it connected a continent by railroad, and the largest gold deposit ever discovered, found in 1886 in Witwatersrand, South Africa, a reef of gold-bearing rock stretching for hundreds of kilometers, still being mined today, still the source of more gold than anywhere else on Earth. Step 1. Get it out of the ground and crush it. Modern gold mining happens in 2 main ways. Open pit mining. Enormous open craters dug into the Earth's surface, where rock is blasted with explosives and hauled out by trucks the size of houses. And underground mining, where shafts descend kilometers into the earth to reach gold-bearing ore seams. The largest open-pit gold mine in the world, the Muruntau mine in Uzbekistan, is so vast that the entire pit can be seen from space. It has produced more gold than any other single mine in history. Once blasted out, the gold-bearing rock is transported to a crusher. Giant rotating mills grind the ore into fine powder, sometimes as fine as talcum powder, to expose as much gold surface as possible for the chemical processes that follow. Step 2. The most controversial step: cyanide leaching. Here is a fact that surprises almost everyone. The most common way to extract gold from ore today involves one of the most toxic substances known to science: cyanide. The crushed ore is placed onto large lined pads or into tanks, and a very dilute solution of sodium cyanide is washed over and through it. Cyanide has a unique chemical property. It forms a soluble complex with gold. Essentially, it dissolves the gold out of the rock into the liquid solution, leaving the waste rock behind. The gold-rich cyanide solution is then collected and pumped to the next stage. The gold is removed from the solution by passing it through activated carbon, a highly porous material with enormous surface area, which traps the gold. The carbon is then stripped of its gold using a hot caustic solution, and the resulting gold-rich liquid is ready for the next stage. The cyanide process, invented in 1887, transformed gold mining. Before it, only high-grade ore could be profitably processed. After it, even very low-grade deposits, like those in South Africa's Witwatersrand, suddenly became economically viable. Step 3. Smelting. Turning liquid chemistry into solid metal. The gold-rich solution recovered from the carbon is now passed through an electrowinning cell, where an electric current causes the gold to plate out of the solution as a solid precipitate. This precipitate, along with any remaining concentrates, is mixed with flux materials, typically borax, silica, and soda ash, and loaded into a crucible inside a furnace heated to over 1,200 degrees Celsius. At this temperature, the gold melts and sinks to the bottom of the crucible. The flux materials bind with impurities, iron, copper, zinc, drawing them to the surface as slag. The slag is poured off and the liquid gold is tipped into ingot molds. What comes out is called a Doré bar, a rough, uneven, dull-colored bar of metal that is typically 70 to 90% gold, with the rest being silver and trace impurities. It doesn't look like the gleaming gold bars you imagine. It looks more like a dirty silver brick. But the Doré bar is then shipped to a specialized gold refinery, and what happens next is where the real magic occurs. Step 4. The two processes that create truly pure gold. The Doré bar arrives at a refinery where it goes through two sequential processes, each developed in the 19th century and still used today. First, the Miller process. The Doré bar is melted in a furnace, and then chlorine gas is bubbled through the liquid gold. Chlorine reacts with all the impurities, silver, copper, zinc, forming chloride compounds that rise to the surface as slag. Gold itself does not react with chlorine at this temperature. After the Miller process, the gold is approximately 99.5% pure. For most applications, jewelry, coins, industrial use, 99.5% is sufficient. But for investment-grade gold bars, electronics, and the most demanding uses, you need higher. Second, the Wohlwill process. The 99.5% pure gold is cast into anodes and lowered into a bath of hydrochloric acid and gold chloride. An electric current is passed through. The gold dissolves from the anode and redeposits on a 5 facts about gold that will genuinely change the way you think about it. Fact 1. All the gold ever mined in human history, across 6,000 years of mining, would fit inside a cube measuring just 22 meters on each side. That's roughly the size of a large house. Everything, every pharaoh's tomb, every gold rush, every central bank vault, every piece of jewelry ever made. One house-size cube. Fact 2. The oceans contain an estimated 20 million tons of dissolved gold, far more than has ever been mined from the land. German scientists attempted to extract gold from seawater in the 1920s to pay off World War I debt. They found the gold was there, but the cost of extraction was vastly more than the gold recovered. It remains commercially impossible today. Fact 3. Your smartphone contains approximately 0.03 grams of gold, mostly in the circuit board connectors and processor contacts. There are now more than 8 billion smartphones in existence. The total gold in the world's phones is estimated at over 200 tons. Electronic waste is now being called urban mining. Some phones yield more gold per ton than an actual gold mine. Fact 4. Gold does not rust, tarnish, or corrode under any normal conditions. It is the most chemically stable metal known. Gold artifacts buried for thousands of years emerge from the ground looking exactly as they did when buried. No other common metal does this. That is the core reason every civilization has valued it. It is the only material that looks the same at the end of time as it did at the beginning. Fact 5. Gold is being used in cancer treatment. Nanoparticles of gold are injected into tumors and then activated using infrared light, which heats the gold and destroys the cancer cells around it. The same metal used in Tutankhamun's burial mask is now 5 grams in a ton of rock, 4 kilometers underground. 6,000 years of human obsession, 2 19th century chemical processes, 1 house-sized cube of everything ever mined. Gold is not special because it is rare. Platinum is rarer, rhodium is rarer, palladium is rarer. Gold is special because it is the only material that never changes. It was perfect 6,000 years ago, and it is perfect today. In a world where everything rusts, corrodes, fades, and dies, gold simply doesn't. And somehow, from tons of gray rock blasted out of the deepest mines in the world, That permanence can be extracted, refined, and held in your hand. Every object has a file. Every material has a story. We're only just getting started. Subscribe and join us for the next one. The Object Files. Every object has a case.